us see this example. Here, all edges of a cube are expanding at a rate of 4 centimeters per second. Okay, suppose there is a cube there. Okay, and all the edges of this cube are expanding at a rate of 4 centimeters per second. So let us assume that the length of each side of the cube is x centimeters. So what it is saying is, this is dx over dt equals to 4 centimeters per second. So rate of change of the side, all the sides are expanding at the rate of 4 centimeters per second. All these are expanding at the same rate. Okay, how fast is the volume changing? What is it asking is dv over dt equals to what? This is asking where given as x equals to 10. When you find out the dv over dt, and then if there is any x, you will plug in x equals to 10. Okay, so what is the formula for v? We know that v is equals to x cubed, right? For a cube, the volume is, for a box, the volume is L times B times the h, right? L times W times h. But since cube has all these are x, x, and x, so it will be x times x times x. So the v is x cubed. So what will be dv over dt? I'm basically finding the derivative with respect to t. So it will be dx cubed over dt, right? So this will give you 3x squared times dx over dt, right? So what it is asking is, it is asking the dv over dt. So dx over dt is 4 and x is 10. So let's plug in that. 3 times 10 squared, right, times dx over dt is 4, right? So what do you get? So 1200. So it is 1200 centimeter cubed per second. Okay, let us do another example. So this is the final answer for this example. Okay, the second example here on this page is, the sand is falling off a conveyor. This is a conveyor machine. Okay, it is rotating, and then it is picking up the sand here. Okay, and then it will drop the sand here, and the sand is making a cone shape here. Okay, so sand is falling off a conveyor of a gravel plant onto a canonical pile at the rate of 16 feet cube per meter. Per minute. So here the sand is falling off on this on this cone shaped pile. Okay, and then how much sand is falling here is 16 feet cubed per minute. Okay, so the dv over dt is 16 feet cubed per minute, and the diameter of the base of the cone is 3 times the altitude of the rate. So the diameter is basically, so what it is giving is 3 times the height is equals to the diameter. But what is the diameter? Is 2 times the radius, right? You can write 2r equals to 3 times h. Okay, at what rate the height of the cone is changing? It is asking dh over dt equals to what? That's what it is asking. You see that? And 3h equals to d, diameter is equals to 3 times the height, right? That's what it is given. The diameter of the base of the cone is 3 times the altitude of that. 3 times the altitude. 3h is equals to d, but I want to write the d in terms of r. So 2r equals to 3h. Okay, so the question is, what is dh over dt? So to do this problem, you need to know the formula for the volume. So formula for the volume of a cone is given by 1 over 3 pi r squared h. Okay, so v is given as 1 over 3 pi r squared h. And now what I want to do is, since 2r equals to 3h, I want to divide by 2. I'll get r equals to 3 half h. Okay, I'll replace that, and I'll keep everything in terms of h, so that when I find the derivative, I will be able to find out dh over dt from here. So which is equals to 1 over 3 pi r is 3 over 2h squared times h, right? So this can be written as 1 over 3 pi, this is 9 over 4 h squared times h. So if you simplify this, what do you get? If you simplify this 3, so it will be 3, right? So you will basically get pi over 4, pi over 4, 3 pi over 4, right? Because there is 3 left. 3 pi over 4 h cubed. Now what we want to do is find out the derivative with respect to h. So differentiating with respect to h will give you dv over dt equals to, this is a constant, so 3 pi over 4 times dh cubed over dt, because this is a constant, so I pull that out. So what do you get? You get 3 pi over 4, but what is the dv over dt? It is 16, right? So 16 equals to, you get 3 pi over 4 and then times 3h square times dh over dt. This is what you get, right? So so what is the h though? The h is when the height of the pile is 22, right? So by the way, let me write down that h also 22 there, okay? So you see that you will plug in that h equals 22 and then solve for dh over dt. What do you get is 16 equals to, this is 9 pi, right? So 9 pi times 22 square over 4 and then times dh over dt. So you just simplify that. If you use calculator, you will get 16 equals to, it is 1089 pi times dh over dt. This is what you get. What you do is this 22 is basically that 22 is 22 times 22, right? Because 22 square. Then divide that by 2 will give you 11 and then 2, and then divide that by 2 again, 11, and then that will cancel out, right? So you'll get 9 times 11 times 11. That's what you will get, okay? And then there is still pi. That is 1089 pi. All right, guys? So the next thing is you divide by 1089 pi. 1089 pi. And then divide by 1089 pi. So what do you get? If you do that, that will cancel out, right? So basically the final answer will be dh over dt equals to 16 over 1089 pi. This is the final answer. But what is the unit? This is a feet per minute, right? Because this is given in the feet per minute form. So this is the final answer. Let us look at another example. It says a ladder 25 feet long is leaning against a vertical wall. The base of the ladder is pulled away at the rate of 3 feet per second. Okay, so this is the ladder, this is the vertical wall, and this ladder length of the ladder is 25 feet per. This is 25 feet. And let us assume that the base length of the base is x and length of the height, or the height is y. So what is given? Find the rate of the change of the top of the ladder when the base is 15 feet away from the wall. What it is? Let me write down the given things first. So the length of the ladder is 25 feet. That's okay. And then the base of the ladder is pulled away. So dx over dt is given by 3 feet per second. This is given, right? So this is moving away by 3 feet per second. Find the rate of change of the top of the ladder. What it is asking is dy over dt equals to what on the first problem? If the base is x is 15 feet. When the base is 15 feet, we need to find out the height of the we need to find out the rate of change of the height. Okay, so how do I find out that? We need to find out the relationship between x and y, so that we can use this thing, right? So look at this. This is the right angle triangle, right? Because the wall is vertical. This is the right angle triangle. So we can use the Pythagoras theorem, right? If you use the Pythagoras theorem, what does that say? It says that x square plus y square equals to 25 square, right? That is basically the Pythagoras theorem. Now we need to find out the derivative. Let's find out the differentiation, because the question is asking the rate of change. Okay, and dx over dt is given, dy over dt is x. So if you find out the derivative of this one, it will be dx square over dt plus dy square over dt equals to d 25 square over dt. What is the derivative of x square? It is 2x times dx over dt, right? plus this is 2y times dy over dt equals to 0, because the derivative of the constant will be 0. So if I rewrite that and plugging in the values, it will be 2 times 15, because x is 15, and times dx over dt is 3, right? Plus 2 times, we need to find out y, we don't know what is y, times dy over dt is stays dy over dt equals to 0. But I need to find out the value of y. When x is 15, when this is 15, this is 25, right? So y will be, when x is 15, then what will be y? So it is like the base square plus the altitude square equals to the hypotenuse square, right? So you can write basically, let me find out that in separately. I want to do here, what I want to do is I want to show you, okay? So it is x square plus y square equals to 25 square, right? So x square is, because when x is 15, so you will get 15 square plus y square equals to 25 square, right? So let's subtract 15 square. 15 square minus 15 square. So you'll get y square equals to 25 square minus 15 square is how much? Let me find out that. 25 square minus 15 square is basically 400. So y is equals to 400. Y square is 400. So y will be basically 20. So let me write down that. In that case, when x is 15, y will be 20. Okay. So, and I will plug in that. So how much is that? 15 times 2 is 30 times 3 is 90, plus 2 times 20 times dy over dt equals to 0. Now I need to subtract 90 from both sides, okay? Let me subtract 90 from both sides. I get minus 90, okay? I will get 40 times dy over dt, okay? So I get 40 times dy over dt equals to negative 90, right? And then what do you get? Divide by 40. Divide by 40. Divide by 40. You'll get dy over dt equals to negative 9 over 4, right? 9 over 4. This is the final answer. You see that? So the rate of change of the height is negative, meaning that this y is decreasing. Whenever it slides away from the wall, then this height will be decreasing because it will fall down, right? That's what it is falling down. It is decreasing with the rate of negative 2.25, right? Like negative 9 over 4 is negative 2.25 feet per second. Okay, that is one question. And another question related to the same example is find the rate at which the angle between the ladder and wall is changing. Let us make the figure for that. So how does that look like? So it is x, this is y, right? And this, you need to find out how fast this is changing. Let's say this is theta, okay? While it's changing when the base is 15 feet. So when the base is 15 feet, we need to find out how fast is that changing, okay? So how do I do this problem then? So to find out the angle, look at this. So how do I relate that? How do I relate those two things, okay? So dx over dt is still given. So let me write down the given things. So dx over dt is given as 3 feet per second, right? This is given. And how do I find out the dy over dt? So to find out the dy over dt, so we need to use the relationship between the, see, this is y, this is x. What trig ratio relates y and x? By the way, there is a right angle triangle there, right? What trig ratios? This is 25 given. What trig ratios relate y and x? That is, look at this. What is given is dx over dt is given, right? So the rate of change of the x is given, okay? The hypotenuse is given. What ratio relates the angle, and then this is the opposite, right? Because this is the reference angle, this is the adjacent side in the right triangle, and this is the opposite side, right? So this is the hypotenuse. So what ratio relates the opposite side and the hypotenuse? That is sine theta, right? So what I want to do here is sine theta equals to x over 25. Okay, now I want to differentiate. Here. So let's differentiate these. I get cosine theta d theta over dt equals to 1 over 25 times dx over dt, right? So what is dx over dt? It is 3, right? So basically this is 1 over 25 times 3. So basically what you got is 3 over 25. Now I want to divide both sides by cosine theta. What do I get? Divide both sides by cosine theta. Cosine theta, divide that by cosine theta. Then I will get d theta over dt equals to 3 over 25 cosine theta. Okay. Now we need to find out the value of cosine theta to find out the value of d theta over dt, which is asked. Because what it says, find the rate at which the angle theta between the ladder of the wall is changing. Ladder and the wall is changing. So this is basically asking d theta over dt equals to what? That's what it is asking. And we took the right triangle and we took the ratio sine theta is x over 25 because sine theta is opposite over the hypotenuse. And then I just find out the derivative and plug in the value of dx over d theta. Now I need to find out cosine theta. So how do I find out that? When it is asking when the base is 15, when x is 15, that is the base of the ladder, ladder and the wall, right? When x is 15, what will be y? We found out that y already, right? When x is 15, y is 20, right? So y is 20. This implies, what is the cosine theta? Cosine theta will be the adjacent over the hypotenuse, right? So that will be 20 over 25. That is the value of cosine theta. I will plug in that here, okay? So therefore, d theta over dt equals to 3 over 25 times 20 over 25 here in the denominator. Now what you do is you try to cancel that 25 and 25 cancelling out. This will give you 3 over 20, right? So that will give you 3 over 20. Is that feet per second? Yes, feet per second. So this is the final answer. 3 over 20 feet per second is the final answer. Here the rate of change of the height is given by rate of change of the base is given by 3 feet per second, and in the first problem we did rate of change of the height y is negative 9/4, and the next one we did the rate of change of the angle. That angle is 3 over 20 radian per this is not feet, this is radian per second because this is the angle, right? So this is radian per second. So I want to write RAD, radian per second, because this is given in the sine cosine. Okay, so if I ask you to find out what is the rate of change of the area of this triangle, so to find out the area, what is the formula for the area? 1/2 altitude times the base, right? So you do 1/2 altitude times the base, but you will have 1/2 xy, and you will have to find out the derivative of that. Okay, but before you find out the derivative, what I suggest you to do is you need to change that y and x in terms of x only. So for example, the y will be it will look like, for the area it will look like this. Okay, let me show you how that look like. Okay, so it will look like area will be 1/2 x times the y, right? But there are two variables, so you need to change that to 1/2 x times root under 25 minus y square, and you find out the derivative, 25 minus x square, and you find out the derivative using the product rule. So wherever you get dx over dt, you will have to plug in the 3, and then x and y will be given at that time. If I ask you to find out the rate of change of the area, which is in the online homework, okay, you do that by yourself. And the very last example I want to do here is this. A man who is 6 feet tall walking away from a light pole or the light post. Okay, there is a light post here. This is the light post which is 15 feet tall, that is given here, and a man is walking away. He is going away from the light pole. at the rate of 4 feet per second. He is walking 4 feet per second. The light pole, the light is at the height of 15 feet. That is at the height of 15 feet on the pole. Okay. So the question is, when he is 10 feet from the light post, when that distance is 10 feet, find the rate of change of the tip of his shadow. So how fast that tip is changing, how fast that tip is changing. That's what the question is asking. Okay, and that's the first question. And the second question is, in A, in the same situation, find the rate at which the length, this length is changing. So you want to find out the overall change in the overall length, okay, as well as change in the this length. So the length of the rate of change on the tip of this is means how fast is this changing when he is going away. How fast is that tip is changing? Meaning, suppose that this is x. The x is the distance between the light post and the man, and the y is the distance between the light post and the tip of his shadow. Okay. On the first question, let me first write down the given thing. Okay, the given thing here is d. So this is 6 feet, and the walking away. So dx over dt, because this distance is changing as 4 feet per second, right? Because what it says is the man is walking away at the rate of 4 feet per second from the walking away from the light post at the rate of 4 feet per second. So that x is increasing with 4 feet per second, right? And on the first one, if he is 10 feet from the so what it says is, when x equals to 10, you need to find out d y over dt equals to what? This is what it is asking. And on the second one, in A, basically this is this similar thing. So I will do the second one right here. So for the second problem, let's write on the given thing. So which is the given thing is same, meaning that when he is 10 feet from the light post, this is same on the B as well. So the question is asking when x is 10, you need to find out the rate of change of the his shadow, length of change of shadow. How much is it? This is his shadow, right? How much is this length? This is y minus x, right? So what it is asking is d over dt, and then y minus x equals to what? This is what it is asking. Okay. All right, guys. So let us do the first problem first. So you see that this big triangle is similar to that triangle. You see that? You can see that this is another triangle. This has 90 degree. This angle is, both of the triangle are sharing the big triangle and the small triangle. They are sharing that triangle. Both of these are 90 degrees. So the remaining angle must be the same. So they are the similar triangle. So their sides must be proportional. Meaning you can write 15 over 6 is equals to, what you can write there is 15 over 6. The big over the small height is equals to y. This is the big length over the length of that base, right? So it will be y over y minus x. Y over y minus x. This is what you get, right? Now what I want to do, I want to simplify this. I want to do the cross multiplication. So you will get 15y minus 15x equals to 6y. You see that? So I want to do that remaining problem here. So what do you get? So 15, let me write down that again. 15y minus 15x is equals to 6y, right? Let me subtract 6y. Let me subtract 6y, and then add 15x. I want to add 15x, okay? Plus 15x plus 15x. So what do you cancel? You cancel 15x and 15x, 6y and 6y. So what is left there is basically 15y minus 6y is 9y is equals to 15x. You see that? So what is y then? 15 over 9x. Now you need to find out the derivative because the question asking dy over dt equals to what? Let's differentiate. If you differentiate, what do you get? Dy over dt equals to 15 over 9 dx over dt. What is dx over dt? Dx over dt is given as 4, right? So let's write on that. 15 over 9 times the 4. So what do you get? You get, let's divide, let's cancel out these things. So divide 15 by 3, 9 by 3 is 5. So 20 over 3, that's what you get. So I get, this is basically dy over dt is 20 over 3 feet per second. This is what you got. Okay. So the next thing is, number B is, in A is the same when he is 10 feet away from the light post. Find the rate at which the length of the shadow is changing. Again, the length of shadow here is y minus x, right? You want to find out the rate of change of the length of the shadow. So when x is 10, what is the rate of change of y minus x? So this is dy minus x over dt is equals to dy over dt minus dx over dt, right? Now we just plug in that. What is dy over dt? We find out that, right? Dy over dt is 20 over 3. 20 over 3 minus dx over dt is 4. That is given, right? So you just simplify that. So what you get is 20 minus 20 over 3 minus 4 is 12 over 3, right? So this is basically 8 over 3 feet per second. This is the final answer. Okay, guys? This is the end of the section 2.6. Thank you.